Hello everyone, we are from the Antibody and Product Development Lab in Bioinformatics Institute, A*. So today we will be presenting to you our application GelApp. So GelApp can be used to help researchers to calculate band sizes on gel electrophoresis tests. So there are 4 buttons in the main menu. The first button allows us to perform a DNA analysis on a gel electrophoresis test image. The image can be from a cyber green or ethidium bromide gel or any black and white image. The second button is the protein analysis button that can be used to analyze gel electrophoresis tests from a page gel. So today we will start by creating a new marker. So we will click on the Save Markers button. And we will create a protein marker standard to be used in the calculation process. So we can load an image from either our photo gallery or Dropbox. Sorry, wrong image. So once the image is loaded, we can actually adjust the properties below the image to ensure that the bands are represented by black blobs on a white background. But as you can see, this image is currently in the wrong color scheme, and we can flip it by clicking on the Inverse Image button. So once you're done, we can click on Next to start detecting the bands. So we'll have to enter a minimum size in pixels to ensure that only bands of that size will be detected. So the rectangles are actually drawn to encapsulate the bands during the detection. So we'll move on to the editing interface, where we can actually erase marker bands by dragging a rectangle across after clicking on the Erase button. We can also add bands by clicking on the Add Marker Band button and then dragging a rectangle on the marker band that has been missed during the detection process. So once you are done, click on the Done button at the top and confirm your changes. So at this page, we will assign a value to each of the marker bands. So these values will be used during the calculation in the generation of the logarithmic graph. So once you're done, click on the Save button and give your new marker a name. And we will be redirected to the main page. Today we will be performing a protein analysis. So we can click on the Protein Analysis button and select the marker we have just created. So we can once again load the gel electrophoresis image from our photo gallery or our Dropbox account. Okay, once the image is loaded, we can actually crop it to remove undesirable objects such as shadows and stains. And once the image is properly cropped, we can click on Next to proceed to the next function. So we can actually brighten or darken the image to actually diminish or intensify the objects on the image. So if the image is in the wrong orientation, we can also flip it 180 degrees. So if it's not in landscape mode, landscape orientation, the image can also be rotated in 90 degrees, either clockwise or anti-clockwise. So depending on the quality of the image, there might be background noises that can actually interfere with the detection process. So we can actually apply a Gaussian blur to remove this background noise. So this is the Gabor filtering page for the gel electrophoresis analysis. So instead, we can change the properties below, or we can click on the recommended settings to apply a preset filter onto the image. So this recommended setting does not work for each and every image. So it is still up to you to adjust the properties, the filtering properties accordingly to ensure that the image and the bands are properly detected as blobs. So once again, we have to enter a minimum size to ensure that only the bands of significance are detected. So once the rectangles are drawn, we can actually click on the image itself to start the editing of the marker and the fragment band's position. So we can erase by clicking on the erase button any bands that have been detected. So we can either drag a rectangle across, or we can click in between the bands to remove that selected band. So if there are erroneous or if there are fragments that have been missed out during the detection, we can click on the Add Fragments and draw rectangles on the positions where we want to detect. So once you're done, click on the rightmost button to save your changes. We can now click on the load marker to see which value have been assigned to the marker bands. So these values are derived from the marker standard that we have saved previously. So if there are any erroneous values that have been assigned, we can also change it by clicking on the image. So a logarithmic graph will be generated to actually calculate the sizes, the band sizes of the unknown fragment bands. So we can view the logarithmic graph by clicking on the View Graph button. And these values of the unknown fragment bands will also be displayed on the final image over here. So the values are actually displayed on top of each band, so for future or further analysis. So if you want to perform an instantaneous calculation at a specific point, you don't have to return to the previous activities to draw the rectangles again. You can click on the Values at Point button to perform an instant calculation of the band sizes by clicking on the image itself. So if there are too many instant calculations, you can also click on Clear Values to remove all of them. So once all the calculation has been done, you can click on the Done button to export the image onto your photo library. Okay, so we have come to the end of our presentation. We hope that you enjoy and find GelApp useful for your research. So once again, we would like to present to you GelApp, which has been developed by the Antibody and Product Development Lab. Thank you.